Graph the solution set of the system of inequalities. 2x minus y is greater than 6, and 4y plus 12 is greater than or equal to negative 3x. I think I'm going to start out by rearranging this inequality and getting my x's and y's on the same side. So I'm going to add 3x to both sides. So it becomes a 3x plus 4y is greater than or equal to. Now let's subtract the 12 from both sides. That makes that a negative 12. So we've got our two inequalities here, numbers 1 and 2. Let's start by graphing the boundary lines for each of these. So for the first inequality, the boundary line is 2x minus y is equal to 6. Let's use a t-table to generate points on this line. If x is 0, then negative y is 6, or y is equal to negative 6. And if y is equal to 0, then 2x is 6, or x is equal to 3. Now as we graph this boundary line, we're going to use a dotted or dashed line because our inequality statement is a strict inequality. That's 2x minus y is greater than 6. So this graph is going to go through the point 0, negative 6. That's down 6 on the y-axis. And it's also going to go through the point 3, 0. That's over 3 on the x-axis. We said we're going to graph that as a dotted line, or a dashed line, you might say. Now, let's decide which side of that line to shade. I'm going to choose the origin as a test point. So let's test the point 0, 0. In the original inequality, 2x minus y is greater than 6. Substituting 0 for x and 0 for y, we'll get 0 on this left-hand side. And is 0 greater than 6? No, it definitely is not. That is a false statement. Therefore, the point that is the origin at 0, 0 is not part of the solution region. So the other side of this boundary line is part of the solution region for that particular inequality. Now let's look at our second inequality statement, and let's graph the boundary line. 3x plus 4y is equal to negative 12. Once again, using a t-table, letting x and y equal 0. In this equation, if we let x equal 0, 4y is negative 12, or y is equal to negative 3. If we let y equal 0, then 3x is negative 12, or x is equal to negative 4. So the boundary line for this region is going to go through the point 0, negative 3. That's x equals 0, y equal negative 3. It's also going to go through negative 4, 0. That's x equal negative 4, y equals 0. As we graph this line, we're going to graph it as a solid boundary line because our inequality does have the equal to sign as part of its statement. So graphing that line as a solid line. Now let's determine which side of that line to shade. Using the origin as a test point, and substituting 0 for x and 0 for y into our inequality statement, 3x plus 4y is greater than or equal to negative 12. Substituting 0 for x and 0 for y gives 0 on the left-hand side. And is 0 greater than or equal to negative 12? Yes, 0 lies to the right of negative 12 on the number line, so that statement is true. Therefore, the origin is in the solution region for our second inequality. Therefore, we'll shade above that line. Now, as a solution to the system of inequalities, the solution region includes this area that is covered by both inequality solutions, this area of intersection of the shading. So I want you to shade this area a bit darker. So we can clearly identify that solution region, and it's the solution region for the system of inequalities 2x minus y is greater than 6, and 4y plus 12 is greater than or equal to negative 3x.